Okay, Professor Jim Schultz here from my Finance 680 class. I wanted to, man, we've had a tough go at it with these 2 snow days, and so with the help of one of your fellow students, thank you, Fahad. He texted me and gave me this suggestion to shoot just a really short little tutorial on the EAR, and so some of this is going to be an overlap of what my email said, but hopefully I can help your studies even more so by kind of going through this, by talking through the basics of EAR, and hopefully you guys will have a better understanding of this concept from having seen this video. And so let's begin with we've got the basic EAR equation right here. And like I said in my email, I'm definitely gonna expect that you guys can apply this in its most basic form. And so this is your EAR, your effective annual rate. It's going to be equal to 1 plus, that's your APR, and then M is the number of compounding periods within 1 year. And so you see M there in the denominator and M as the exponent. So if you have, for example, when you have like monthly compounding, M is going to be 12. If you had daily compounding, M would be 365, and so on and so forth. Okay, and of course your APR here has to go in as a decimal. And so this is your basic EAR equation. This is just one example of how to compute an EAR. So this line actually right here where my cursor is, this is extremely important. And so this is like the main reason why I shot this video, because what's up here and what's down here is kind of in the email already or in the textbook. And so, but right here, this is really important. When you read this line, 12% compounded monthly, how do you interpret that? This is extremely important. Students usually get tripped up on this until I'm able to kind of clarify any confusion that they might have. That right there is still an annual number, just like we have learned in class. Alright? 12% compounded monthly is to be interpreted as 12% per year compounded monthly. So this is not a monthly rate. You're not earning 12% per month. That's still an annual rate. That's just referring to how often that rate is being compounded. So make sure you understand that when you read something like 12% compounded monthly, 8% compounded weekly, 10% compounded bi-weekly, and so on and so forth, the first number is still annual. What flows behind it is going to refer to its compounding frequency. Alright? And so then you can just plug this guy right into this equation, and it's a pretty simple computation. There's your APR, which is of course going to be your nominal rate, which is right there. Number of compounding periods per year is 12. You see that show up in both spots. Take one off, you get 12.68 in this example. Just a real quick suggestion or tip. Remember the order of operations here. So I would do this division first, then add 1, raise to the exponent, subtract 1, and boom, there you go. Now, this bottom half, and the last thing I want to get into here, if you have a problem that you are not sure that you need an EAR, how do you determine if you do need an EAR? Alright, well, I have found that these 2 conditions really help students out in terms of determining if they need an EAR. Again, like I said in my email, if the problem says find the EAR, obviously you need to find the EAR, right? We're all pretty squared away on that one, I would think. But what about a problem where it doesn't come right out and say you need an EAR, and it's giving you compounding frequencies and payment frequencies and all these different things, and you're trying to figure out, do I need an EAR at some point in this problem? Alright, well, these 2 conditions, and you must have both to require an EAR for solving the problem correctly. These 2 conditions will help you determine if you need the EAR. Number 1, and you should actually do these 1, 2, do them in this order. If you have non-annual compounding, you might need an EAR. Okay? If the problem has annual compounding, you're not going to need an EAR. Period. You can move forward, don't have to worry about it. Alright, so that's why I like to look at this one first, because if this one is not met, then you're not going to need an EAR at any point in the problem. then you have to look at both the payment frequency and the compounding frequency. If they are different, if they are not the same, then along with non-annual compounding, yes, you're going to need an EAR in that problem. So number 24 and number 25 are good examples of this. In number 24, if I recall, I don't have it in front of me, but if I recall, you had monthly compounding, so condition 1 was met, but you had monthly payments. So condition 2 was not met because the payment frequency and the compounding frequency were equal. Therefore, you did not need an EAR for that problem. However, number 25 was a continuation of number 24. So you have non-annual compounding with the monthly frequency, but you also had an annual payment required in that problem. Therefore, both conditions 1 and 2 were met, so you did need an EAR as you saw in my solutions. And so hopefully now, with my email and also with this little video tutorial, it's a little bit more clear what I'm looking for in terms of EAR applications. Now, more complicated problems like number 52, number 59, that's beyond the scope of this video. However, this weekend, I think I'm going to try to put together a video tutorial for one of those problems so that you can kind of see how EAR shows up in a slightly more challenging format. So I hope that this was helpful for you guys.